First, note down different values given in the question. So in this question, go through first sentence of the question. Each ball of a governor, Hartnel governor, has a mass of 1.5 kg. So mass of ball is small letter m. Small letter m is 1.5 kg. The other arms of bell crank lever lift the sleeve against force exerted by spring which is under compression. The meaning of this sentence is that in this Hartnell governor, they have fixed one spring. We will not consider any value from the sentence. Length of the ball arm and sleeve arm are 125 and 75 mm. So these two arms, if you consider, this is ball arm A, this is sleeve arm, and the dimension is B. So in the question, length of ball arm is given. Length of ball arm is 125 mm. We'll write it in terms of meter. 0.125 meter. This is the length of ball arm given here. And length of the sleeve arm, that means B value. B value is 75 mm. We'll convert that into meter. 0.075 meter. Next sentence. Fulcrum is 90 mm from the axis. Fulcrum is 90 mm from the axis means this distance is given. This distance, it's nothing but R value. Fulcrum is, this is the fulcrum point. This is the fulcrum point. Fulcrum is 90 mm from the axis. That means R value is given. Small letter r is 90 mm means 0.09 meter. Maximum and minimum radius of rotation is given. Maximum radius of rotation is R2 and minimum is R1. R2 value is 115. That means 0.115 meter. And R1 value is 0.075 meter. Sleeve begins to lift at a speed of 300 rpm. That means N1 minimum speed is given. Sleeve begins to lift means that will be minimum speed always. (300 rpm). And in the next sentence, it is given that maximum speed is 6% greater than minimum speed. So maximum speed N2 is 6% greater than 300. So you can find a value of N2, N1 plus 6% greater. 6% means 6 divided by 100 into N1. So when you substitute, you will get N2 value 318 rpm. Value of N2 you will get 318, 6% greater than N1. You have to find rate of spring or spring stiffness. That means value of S you have to find out. and also equilibrium speed for the radius 90 mm. That means when the radius of rotation is 90 mm, you have to find out what will be n value. So here n1 is minimum RPM, n2 is maximum speed. What you have to find out is when the speed is when the radius is 0.09 meter, what is the speed? So when the radius is 0.075, speed is 300. When the radius is maximum, speed is maximum. When the radius is minimum, speed is minimum. You have to find speed when radius is 0.09. So first we'll calculate spring stiffness or rate of spring, and the equation is this equation you have to remember: 2 times a by b whole square into F2 minus F1, equation for spring stiffness, divided by R2 minus R1. So in this equation, value of A and B is given. Value of A is given here, value of B is given. R2 and R1 values are given. R2 is given, R1 is given. F1 and F2 values are pending. You can calculate what is the value of F1 and F2. Equation for F1 is m omega 1 square into R1, where omega 1 is equal to 2 pi n1 by 60. 2 pi n1 divided by 60. So first calculate omega 1. Calculate omega. I know the value of n1, it is 300 rpm. After calculating omega, then calculate f1 value. You will get f1 value 111.03 Newton. 03 Newton. Then calculate value of f2. F2 equation is m omega 2 square into R2, where omega 2 is 2 pi n2 by 60, where omega 2 is equal to omega 2 is equal to 2 pi n2 divided by 60. You know n2 is 318 rpm. Substitute and you will get the value of f2 as 191.129.29 Newton. Substitute value of f1, f2, a, b and r1, r2 in spring equation, spring stiffness equation. You will get spring stiffness as final answer. S value you will get 11,147. This is 147.73. Unit of spring stiffness will be Newton per meter. Unit of spring stiffness will be Newton per meter. So that completes first sub question. Calculate rate of spring or stiffness of spring. Now second sub question is pending. You have to find out what is equilibrium speed for radius of rotation 90. For this, I will use the equation F minus F1 divided by R minus R1 is equal to F2 minus F1 divided by R2 minus R1. R2 minus R1. Equation is F minus F1 divided by R minus R1 is equal to F2 minus F1 divided by R2 minus R1. Textbook procedure is slightly different. So in this equation, I know the value of F1. Value of F1 is known. Value of F2 is known. Value of R1 is known. Value of R2 is also known. And value of R will be, this R is, it is given in the question, it is 0.09 meter. So only one unknown term is present. Unknown term is capital letter F. Except F, all other terms are known. So you will get value of F as 141.127. This is the value of F. But what exactly you have to calculate? You should not, question is not to calculate what is the force. Question is to find out equilibrium speed. Equilibrium speed means n value. To find out n value, you can equate this force with the m omega square into r, m omega square r, where m is 1.5 kg, m is, this is the last step, m is 1.5 kg. You need not convert into Newton, keep it in kg only, into value of omega is 2 pi n divided by 60 whole square, into value of r is 0.09. Value of r is 0.09. So simplify this one and you will get final answer. Final required answer. Equilibrium speed n value 308.75 RPM you will get. This is the final answer. Obviously, this equilibrium speed should be in between maximum speed and minimum speed. And the answer is 308.75 RPM. We'll quickly summarize this one. Usually they will ask you to find out spring stiffness or rate of spring and also equilibrium speed in most of the question. To find out spring stiffness, you have to remember this equation. There is no second option. You have to remember this one. Where A and B are, A is length of ball arm and B is length of sleeve arm. This is ball arm and this one will be sleeve arm. A and B values are given in the question. And to find out F1 and F2, you have to use equation m omega square r. In this equation, omega is given by 2 pi n by 60. Value of R1 and R2 is given in the question. So substitute every values, you will get spring stiffness. Now second question is to find out equilibrium speed, and that you can find out using equation or using relationship. F1 minus F1 divided by R1 R minus R1 is equal to F2 minus F1 divided by R2 minus R1. In this equation, all the values are known except F. You will get F value 114. And you know F is given by m omega square r. So from this equation, n is unknown. That is the equilibrium speed, and you have to find out what is equilibrium speed, and you will get final answer n value as 308.75 rpm. You can note down final answer. You will get n as 308.75 rpm. So that completes solution of this one.